In today's video, we're going to look at comments, refactoring, and even clean code and how they affect your entire journey as a career, as an engineer, so that you can build better code, ship faster, and ultimately make yourself a better engineer. So let's dive in. Every developer has heard these golden rules of code quality, the ones drilled into us in college or repeated endlessly in online forums. What if I told you most of the common advice out there is just plain wrong? Well, fear not. My name is Kiran, I'm your alchemist, and after a decade of building complex softwares, I firsthand see how these so called practices can destroy your career. Let's kick this off with a classic myth that is there in this industry that comments are always better, or more comments are always better. That may seem lovely, but most of the time not.
5 minutes later.
The sum of the. It has a sum. Let's just keep it that way. All right.
15 minutes later.
Imagine that the implements algorithm has actually the algorithm written inside of it. Now, here, if calculate optimal route did not implement Dijkstra's algorithm and it rather implemented something else entirely, that would have been confusing, right? So if it didn't have, so instead of Dijkstra's algorithm, let's say it says it has implements the A star algorithm instead of implementing Dijkstra. So this comment actually becomes useless for us, right? But also tells you that somebody came along and changed it in your either your code review or in your um, when you're actually debugging the application or troubleshooting the application, right? So having comments in this scenario, particularly this one, the algorithm that needs to be implemented in that function is generally a good case, but implementing comments like this where the function adds two integers whereas the function name is addition itself has no use at all. So now you know when code comments can actually be useful and should be used, but it should be used sparingly. They don't need to be splattered across the entire code base. 100% test coverage is good, is the goal, right? What the test coverage actually tells you, the metric test coverage actually tells you is how much of your code base is actually tested or covered under the tests or unit tests, right? Coverage is not 100%. The test unit testing is not 100%, but that's fine, right? There are cases where people have developed and deployed software which do not have 100% test coverage. In fact, in open source, if you see, there's multiple libraries which are not 100% test coverage, but still being used by majority of large and small businesses alike. So while this is a very good function, it's a very simple function. It gives you clarity on. Tells you what it does. It just gets the user's name from a user object. Test case for this. So that could be a test case written in. Let's say you can do it with your file name.test.js. Should be simple enough. So this means that get username is technically covered under the test cases. What value does this test case, the claim of being 100% coverage, do for me? Like, what value does it bring? Nothing. And I'll tell you why. Because what it's doing here in this test case is very simple. It's just checking whether something in the language works properly, because that's essentially what we are doing. We are taking a function and taking an attribute out of of an object, of a JavaScript object. It's testing whether JavaScript can take out an object for me or not. Basically, that's what it is doing, and it's not testing any complex test cases here, right? These test cases are useless, but yes, you can add more test cases saying that, let's say, instead of user name object as a string, it gave a number, like it entered 123 as an erroneous test case. You want the test to fail, in particular this test to fail, but to fail in a known scenario. Let's take another example.
5 minutes later.
Order discount amount returns the correct order discount amount. Okay, so I'll say items object has price and quantity. Discount percentage is equals to 10. Calculate order discount. So 2 and 3, 5 and 3. Here, discount percentage is 10%. Okay. All right. So now we are doing some sort of complex logic here, right? This test case in this particular complex logic
This
makes sense. It tells you, okay, if the percentage is applied correctly, the answer should be correct. If the values are, taken out correctly by the reduction function, the total summation should be this. That's where test cases actually make some sense. So there's multiple types of tests. What we have covered in this video today is just unit test cases. With integration tests in a similar way, we can go forward with end-to-end testing in a similar way as well. Moving on to our myth number 3, refactoring is a waste of time. Refactoring is very, very, very important. Although, even if I say that refactoring is important, I don't mean that refactoring is the only option when your software is something you don't understand or it's too complex. I would recommend refactoring to be taken up only when you have no other choice to do. Since it's a big endeavor, you will have to do a lot of changes in your code base. You will have to do a lot of changes in your data structures. You will have to do a lot of changes in your business requirements also, to a great extent. And downstream, upstream, whichever function changes, you will have to take care of those as well. So refactoring is not a small undertaking where you know that it's much better and much more efficient. That's where you can do a refactoring. The performance gain is higher, and than just keeping a for loop with a lot of scalability issues that could come in. Spearhead these kind of refactors on the entire product scale. So it's just better that way. Identify whether you need to do a refactor first, and there are some factors that you need to calculate them. Myth number 4: code quality is about aesthetics and readability. This is the funniest one that I've come across, and I've seen multiple sources online which tell me, like, which were saying that code quality is a myth. It shouldn't be done, and it should be pretty. The code should look lovely. It should look lovely, but performance is not concerned. So, okay, let's do it again. Similarly, we do it with an example.
20 minutes later.
Now it seems as this particular code is beautifully formatted. It's inline. There's accurate amount of comments, clear variable names. There's nothing wrong with this. However, it does look clean, but it's tightly coupled to the database. So if tomorrow, let's say you want to test this, you won't be able to do it until you have a full database connection in it. So a process order function will always fail the test case if you don't have the database attached to it. Because of that, you will end up with significant amount of hidden side effects, right? Like, for example, the items in inventory is actually 0. It doesn't handle that case. While it looks beautiful, it processes the order, but it does not process the order properly, right? We can go into deep into the hidden side effects. And the other part that will happen inside of this code is it'll perform very badly under load. Why? Because there's sequential database connections connected for multiple items. Right. So the more connections you make with the database will slow the entire process. And with more amount of orders coming in, you will not be able to scale this code. Code quality is not a myth. Cleanliness of the code, or rather readability of the code, is a big myth. It doesn't need to be beautiful, right? There are people who say line length should be 120 columns. That's not true. Like, I mean, I don't prefer 120, I prefer 80. For me, that is beautiful. For you, 120 line width is beautiful for whatever reasons. Like, it's personal preference. So beauty is something that is definitely not part of your code quality, and it is a myth. Your code should be performant, your code should be readable, it should be understandable and explainable to the next person. When I say readable, I don't mean add comments everywhere. What I mean is your code should speak, right? Even in this example, if you see, the process order function essentially just connects to database and does some jobs, which is clearly visible. Now, I agree this is not a full-fledged real production style code base. Finally, let's tackle the myth that to write high quality code, you must always be on the bleeding edge, using the latest microservice, latest JavaScript framework, or the newest AI service. This myth often leads to severe over engineering. Just because the technology is new doesn't mean it's the right technology to your problem, or that it will automatically lead to higher quality. In fact, most often than not, opposite is true. New tech usually comes with steeper learning curves for you and your team or your future hires. Immature ecosystem, since the technology is very new, it's not tested, it's not battle tested, it's not it has fewer libraries, has less community support, and so on. It also has an unforeseen challenge problem where you're often the first one to hit that problem. And if you're in a production environment and you come across and you shift to a newer technology, what you will end up with is a huge mess of unknown challenges, right? So you don't want your enterprise resource or your production resources going into exploring new solutions and how new technology works. Let's take for an example. You're building a simple internal dashboard. You might use something like Retool, which is a drag and drop builder, right? Been battle tested, very much used in enterprise scenarios because there's a new technology. Let's assume you're using a new, completely brand new technique and you decide to build a new React front end based, NoSQL database based, serverless architecture, dashboard on your own. Now that will lead to a lot of problems. One is you will have to ensure that it is maintained. You will have to it's ensure that the complexity is low, but that's usually not the case with newer technologies or the hype. And the development is fast because if it's an internal dashboard, your internal teams will be using it. It's very much important for you to be able to maintain it and make sure that it works as intended. True quality comes from choosing the right tool for the job. Sometimes you have to choose the battle tested, boring technologies that just work. Don't chase the trends for the sake of it. Stability, maintainability, and understanding of your tools contribute far more to the quality than novelty or newness or trending will ever, contribute. So there you have it. We have covered about 5 coding myths that are busted and exposed. We've seen that more comments aren't always better. 100% test coverage isn't actually a goal. Refactoring is essential and not a waste of time. Code quality is far more than just prettiness of the code. And lastly, that new tech is the latest technologies automatically do not translate to the best quality of software. The core message here is that true code quality is pragmatic, holistic, and deeply impacts the real world outcomes. It's about making informed decisions, understanding trade offs, and continuously improving rather than building outdated rules or blindly following newest, latest trends. You have to challenge these myths. By challenging these myths, you're empowering yourself to write more efficient, maintainable, and robust software. If this video helped you rethink your approach to code quality, please hit that like button. It really helps the channel. What's a code myth you have encountered or struggled with? And let me know in the comments below. I'd love to hear your comments, explore it together, and don't forget to subscribe for more deep dives and more such videos and content. I'm here every week to build you better software faster. Thanks for watching, and I'll see you in the next one. Good.